Hello. Okay. I guess you can hear me now properly. If at any time you cannot, just text me. I was telling you, whenever you look for the graph, and you will be you're expected to see too many graphs in your paper. The quantities on each axis are very important, and uh, this is what you have to look for. Number one, the quantity is r cube, and this is a number that should go with anything that you take from the axis. Any number, for example, if you're picking 4, remember that at 10 to the power 23 has to go with it. So any number has this prefix with it. And on x-axis we have 1 over omega square, which is also in 10 to the power 7 as a prefix. Now, show that the mass m of the planet is given by the expression m equals to gradient over g. As in the previous part, we were talking about centripetal force being provided by the gravitational force. So we can say gravitational force equals to centripetal force. So g m over r square equals to m omega square r. M and m cancelled. Capital M equals to omega square r cube over g. Now, gradient. Now, gradient of any graph is actually quantity on y-axis divided by quantity on x-axis. I hope you all know that the gradient is rise over run. So simply, what you do is you divide the quantity on y-axis with quantity on x-axis. That's why gradient will be rise over run. So that means quantity on y divided by quantity on x. Quantity on y is r cube. Quantity on x is 1 over omega square. So it means r cube divided by 1 over omega square means r cube multiplied by omega square. So gradient omega square into r cube is the gradient. That means m equals to gradient divided by g. So we can say hence shown. Now, use figure 1.2 and expression to show that the mass of the planet is 1 into 10 to the power 26 kg. So what you have to do is you have to find the gradient. Now, there are some very basic rules to find gradient. To find gradient, we have to use as much as possible part of the graph. Bare minimum is more than 50% of the line. Now, for this, I have a very simple solution. When I see a graph and I have to find gradient or anything from the graph, I start looking for a good point. A good point on a graph is a point that passes through the grid intersection on the graph. For example, I can see that this point is very much close to a point on the or the cross on the grid. And what good it will do? It will give me a very good value on x-axis and very good value on y-axis. I won't be looking for any approximations over there. Okay, so I go for a good point on the top. Now go on the other side of the graph and start looking for another good point at the bottom. A good point. So I guess this is All right, because this is passing through the grid intersection. So draw a horizontal line from the lower point and a vertical line from the higher point and complete a right angle triangle. And this is what examiner wants to see on the graph when you're finding gradient. This is 1.5 into 10 to the power 23. This one is 3.9 into 10 to the power 23. This is 5.7 into 10 to the power 7. And this is 2.2 into 10 to the power 7. So 3.9, 1.5, 5.7, 2.2. 3.9 minus 1.5 divided by 3.7 minus 2.2. The denominator will come with a 10 to the power 7 and the numerator will come with 10 to the power 23. So 1.5, 3.9, 5.7, 2.2, 5.7. So by using a calculator, we can find it 3.9 minus 1.5 is 1.4, actually 2.4, divided by 3.5 into 10 to the power 16. This is just the gradient. So whatever answer you get from here divided by 6.67 into 10 to the power minus 11 will be equal to the final answer. So 2.4 divided by 3.5 divided by 6.67, 1.03 into 10 to the power 26, which is approximately equal to 1.0 into 10 to the power 26 kg, hence shown. Now, determine the speed of the moon in orbit around the planet with an orbital radius of this. V equals to R omega. So you have to collect data from the diagram. R given is 1.2, but the graph is drawn for R cube. If R equals to 1.2 into 10 to the power 8, R cube will be 1.2 cube, 1.73, 1 point, just 1 second. I think I lost the connection to the Zoom. Just 1 second. Okay. Now the graph is drawn for uh, r cube. So r cube will be 1.73 into 10 to the power 24. Now go for 1.73 on the graph. 1.7. Go to the graph and you come down. So this is 2.5. So 1 over omega square equals to 2.5 into 10 to the power 7. So omega equals to 1 over 5 into 10 to the power 3. 2.0 into 10 to the power minus 4 radians per second. Now we have omega, we have r. The formula for V equals to r omega 1.2 into 10 to the power 8 multiplied by 2.0 into 10 to the power minus 4, and the answer will be 2.4 into 10 to the power 4 meter per second. So 24 kilometers per second, that is the speed of that moon. Now, now a fixed mass of an ideal gas has a volume V and pressure P. The gas undergoes a cycle of change X to Y to Z as shown in figure 2.1. The figure shows the temperature, figure shows PV and temperature T for the gas at point X, Y, Z. At X, P is 1.5. Again, units are very important. 10 to the power 5, 4.2 into 10 to the power minus 3 meter cube. Temperature is 540. Now, uh, at Y, what is same between X and Y? Look, the value of pressure. So we can say value of pressure will be 1.5. We have to find volume. PV equals to nRT. Let's consider n and r is a single variable, then it will be PV over T. So let's find out this variable. It will be 1.5 into 10 to the power 5. Volume will be 4.2 into 10 to the power minus 3 divided by temperature will be 540. 1.5 into 4.2 is 6.3 into 10 to the power 2 divided by 540. So 630 divided by 540, 0 and 0, and this will be 7 by 6, 1.01, no, 1.1667. So you can say 1.2. So this is the value of n into r, the total of these two values. Can we use this to find the unknown? Now we know the value of n into r is 1.2. Now we need PV equals to nRT. We are looking for V. V will be nr, yani 1.2. T is 230 divided by T is 1.5 into 10 to the power 5. 1.2 into 230 divided by 1.5. So it will be 1.84 into 10 to the power minus 3. So this will be 1.84. And the next one is Z. In Z, pressure has become 5.1. What you can be sure of is the volume. Look, this value of volume is 1.84. What will the value of volume at Z? It will still be 1.84, so it is simply 1.84. State the change in internal energy for you for the complete cycle. Change of internal energy means that how much energy in total has changed from for the whole cycle. Remember, if it is a closed cycle, it means there is no change of internal energy. So internal energy change will be zero. Calculate the amount of mole. That is easy. We have already calculated nr equals to 1.2. Value of r is 8.3. So n equals to 1.2 divided by 8.31. 1.2 divided by 8.31. 1.44. So this will be 0.144. Now, complete the table. Use the space below for any working. We have already done that. The first law of thermodynamics is this: state what is meant by delta U. Change in internal energy, change in heat energy, work done on the system. If it is positive, that is this is work done on the system, and if it is negative, then it is work done by the system. Now, explain how the first law of thermodynamics applies to the change Z to X. Now, we have to change that, explain that how this is a complete uh, circle, or this is a closed cycle. We say that due to increase in the volume, work is done by the system. Whenever any gas expands, it means work is done by the system. And when anything cools down, it means heat energy is lost. Uh, Expansion means work is done by a system means negative W. Cooling means energy, heat energy is lost minus Q. So overall internal energy decreases. Z to X. Actually, you need to see the graph. Z to X, volume is increasing, and we know that Z to X at Z temperature is 782, and at X temperature is 540. If you go to the table, you can see these numbers. This means that heat energy is lost. So overall, from Z to X, overall internal energy is negative. Now, a small wooden block, cuboid of mass m, floats in water as shown in figure. Wooden block is so and so. The top face of the block is horizontal and has area A. The density of the water is rho. State the name of the two forces acting on the block when it is stationary. One of the forces is the weight of the block. And if it is stationary over here and floating, it means there is definitely upthrust or buoyant force. Weight and upthrust due to fluid. The block is now displaced down as shown in the figure, and the surface of the water is higher up the block. Strain explain direction of the resultant force on the wooden in this position. For example, if there is a floating box and you try to push it down, what happens? The object resists to go down. It means there will be an upward force acting on it. Upward force by pushing down, up thrust increases. So net force is upwards. The block in B is now released so that the oscillation it oscillates vertically. The resultant force F acting on the block is given by F equals to minus AG rho x, where G is the gravitational field strength. Excuse me. X is the vertical displacement of the block from the equilibrium position. Explain why the oscillation of the block are simple harmonic motion. Now, for simple harmonic motion, What is the basic condition for simple harmonic motion? Simple harmonic motion requires that the acceleration is directly proportional to force and always in the opposite direction. So they always have opposite signs. So for simple harmonic motion, A is directly proportional to minus x, G equals to x, A and rho are constant. So and F can be replaced with ma. So A is directly proportional to minus x, hence simple harmonic motion. Show that the angular frequency omega of the oscillation is given by now acceleration equals to minus omega square x, and in this case F equals to minus a rho gx. F means ma equals to minus a rho gx, a equals to minus a rho gx, omega square equals to uh, sorry, over m, a rho g over m, and omega equals to a rho g over m square root. So this is how we can show this. The block is now placed in a liquid with greater density. The block is displaced and released so that oscillation vertically. The variation of the displacement of x and the acceleration are measured for the first half oscillation. Okay. Explain why the maximum negative displacement of the block is not equal to minimum negative displacement is not equal to maximum negative displacement, because this oscillation is asymmetric about its mean position. So if mean position is there, then oscillation is not symmetric. Listen, when object is going down, the upthrust is increasing. When upthrust is the object is coming out of the water or the liquid, upthrust will be decreasing. So it means the maximum net force and the minimum net force are not exactly equal. That's why the displacements are not equal either. The mass of the block is 0.57 kg. The figure 3.3 determines the decrease of energy of the oscillation of the first half. Listen, what is the formula for energy? Maximum potential energy equals to 1 over 2 K x naught square. K x naught square. Now for K, mm, 1 over 2 K x naught square equals to 1 over 2 m v naught square. K x naught square equals to m omega square x naught square. So K equals to m omega square. So we can find K now. The change of potential energy will be 1 over 2 K x1 square minus x2 square, and this is how we can find change of maximum energy on both sides. So the values of x naught and x can be determined from here. So minus 1.85, 2.3. State what is represented by an electric field line. Direction of force on positive charge in an electric field is called electric field line. It shows the direction on the direction of force on a positive charge. Okay. Let's have a 10-minute break for the prayer, and I'll be back in 10 minutes. Okay, I'm back. Now, this question is about electrostatics and electrostatic forces. Now, 2 point charges plus 4 nanocoulomb minus 7.2 nanocoulomb. They are 12 centimeters apart. The charge of P is this and this. Determine the distance E of the point joining the two charges where the electric potential is zero. So let's say if there is a point, any point this, This distance is x. This distance is 0.12 minus x. Then we have to find x. So what is the formula for electric potential? K Q over so K K which is 8.9 into what's the exact value of Q? Let me see from the table of 8.9 1 or 8.9. So equals to no, that was one constant electric field. 8.99 into the power. So with 8.99 into the power 9 into 4 and 0 into the power minus 9 divided by x plus 8.99 into the power 9 multiplied by minus 7.2 into the power minus 9 over x minus 12. Sorry, 0.12 minus. Okay. Now, start finding the value of this one itself. We can take equals to 0, 8.99 10 to the power 9 into 4 into 10 to the power minus 9 divided by x equals to 8.99 10 to the power 9. So equals to 10 to the power minus 9 divided by. So we can simply get rid of this, this. So it will become 0.48 minus 4x equals to 7.2x. 11.2x equals to 0.48. X equals to 48 divided by 11, 0.043. So 4.3 centimeters from straight explain whether calculation over conversion whether the electric field strength is zero at the same point at which the electric potential is zero. Actually, electric field strength is the gradient of electric potential graph. We say love, electric, potential, zero, the gradient, the zero, v, y, y, not, zero. An electron's position at x equidistant from P and Q, as shown in figure. Draw arrows to represent the direction of the resulting force acting on the electron. Remember, this is a positive charge, this is a negative charge. Represent the direction of force acting on the electron. Electron will be repelled by this one, slightly downward because of the more charge, and the electron will be attracted towards the positive. So complete the parallelogram. This is how we draw the result. That's it for today.